So the last week has been all about mole conversions and converting between moles and molecules, moles and grams, and moles and liters. But there is one more step that we can kind of look at to kind of finish talking about mole conversions. That is conversions involving molecules and atoms. So we've already discussed the difference between atoms and molecules. That came out at the very beginning of the chapter. And if you remember, we said atoms are for elements by themselves. So that's going to be things like Cu or Mg. If it's one single thing on its own, we're dealing with an element. Molecules, on the other hand, are for a group of atoms that are combined. Most times it's going to be your compounds, things like H2O, CO2, or it can also be your diatomic elements, things like O2, N2. Any of those would also be considered a molecule. So to convert between atoms and molecules, the main thing that you need to be able to do is you need to be able to figure out how many atoms are in a molecule of something. So H2O, there's 2 hydrogens, and there's 1 oxygen. So within that one molecule, there are 3 total atoms. C6H12O6, there's 6 carbon, 12 hydrogen, and 6 oxygen, or 24 total atoms. And something like C2H4O, there's a total of 7 total atoms. And that's what you're going to need to do to figure out your conversion factor. And really from there, everything else is what we've been doing. So what a problem would look like is you're being asked to convert 1.2 times 10 to the 24th molecules of water to atoms. So the first thing you need to do, you need to figure out what is a molecule of H2O. One molecule of H2O contains 3 atoms. So that's going to serve as our conversion factor. That's going to change depending on the substance you're dealing with. So if it's H2O, it's 3. But if it's some other substance, your number of atoms is going to be different. So this is our conversion factor. We set it up just like we've been doing everything else. So 1.2 times 10 to the 24th molecules is the number that we're given. And then we want to convert that to atoms. So we need molecules to cancel out. So molecule needs to go on the bottom. So when we do the math, we get 3.6 times 10 to the 24th atoms. And that would be your answer. If we want to see that in a 2-step problem, it would look something like this. How many atoms are in 0.5 moles of CO2? So we know moles. To go from moles to particles, it's Avogadro's number. The question becomes, well, what is that particle? Is a particle an atom or is it a molecule? CO2 is a group of atoms. It's a compound. So 1 mole is going to be equal to 6.02 times 10 to the 23rd molecules. So that's going to be our conversion factor. It would be great if we could go straight to atoms, but we just can't. CO2 is not an atom, so we have to first go to molecules. We take 0.5 moles times 6.02 times 10 to the 23rd molecules over 1 mole. Moles go on the bottom so that they cancel out. We get 3.01 times 10 to the 23rd molecules. So that's going to be the first step that we need to take. But we're looking for atoms, so we have another step to go. We need to figure out how many atoms are in CO2, and the answer would be 3. There's 1 carbon and 2 oxygens. So now we can convert our number of molecules that we found in the first part to atoms. So there's 3 atoms for every 1 molecule. So molecules have to go on the bottom. You get 9.03 times 10 to the 23rd atoms. Take a look at one more kind of single or step problem here, which is going to be a little bit more involved. We'll do the third one. So we've got atoms. So first we need to figure out how to convert from atoms to moles. F2 is a molecule, so we can't go directly from atoms to moles. We need to go atoms to molecules. And then molecules to moles. So one molecule of F2 contains 2 atoms. So that's going to be our first step, 4.1 times 10 to the 24th atoms times 1 molecule for every 2 atoms, which gives you 2.05 times 10 to the 24th molecules. We can now go from molecules to moles, because we know 1 mole is equal to 6.02 times 10 to the 23rd molecules, and 2.05 times 10 to the 24th molecules times 1 mole over 6.02 times 10 to the 23rd molecules gives us 3.4 moles as our answer. Last thing we can do with this is put it all together and actually have a 3-step problem. So looking at number 1, it says 66 grams of CO2 to atoms. So we start off with grams. The only thing we can do with grams is to go to moles. From moles, we can go to particles. For CO2, that particle is going to be a molecule, and then we can go from molecules to atoms. If you're struggling with this, coming up with a plan, coming up with steps is definitely a good starting point. But first, we need to do grams to moles. So for CO2, 1 mole is equal to 44 grams. Just got to look up carbon and oxygen on your periodic table. 12 plus 16 times 2 is 44. So 66 grams times 1 mole over 44 grams gives you 1.5 moles. We then want to go to molecules. 1 mole is equal to 6.02 times 10 to the 23rd molecules. So we take 1.5 moles times 6.02 times 10 to the 23rd molecules over 1 mole. Moles cancel, giving us 9.03 times 10 to the 23rd molecules. And then our last step is to go molecules to atoms. For CO2, 1 molecule is equal to 3 atoms. So there's 3 atoms for every 1 molecule. So when we multiply that, we get 2.079 times 10 to the 24th atoms, which would be your answer.